All right, we're looking at question 3.3 from the June 2021 question paper. We're focusing on the process of solving math questions. That is what we're doing mainly in this playlist and in the previous one. You are asked to show that the equation of line LQ is y is equals to negative half x minus 6. Do not be confused. If you did not look at the first question in the first video in this playlist, do that because we did a lot of analysis there. But anytime when you're looking at a question, don't be confused. The question itself tells you what to do. It says show that the equation of line LQ, right? Immediately, it's talking about the equation of line. You should remember the formula for the equation of a line. And let's use this one, seems a bit more efficient. X minus x1. I haven't even started answering the questions and the question, and already I'm on the right track, because most students look at the question and then they try to think of an answer somewhere far. You just look at the question, look at the words. They're talking about the equation of line LQ. Now they are referring you to the diagram. LQ. Where is LQ? This is our LQ here. Different color. This is your LQ. This line right here. Right? That's your LQ. This is even better because they just asked you to confirm that it is y is equals to minus half x minus 6. So what you're going to do is just find the equation of that line and compare and see if it's the one they asked you to prove. So what do we need to find the equation of a line? First of all, we need what? The gradient. We need the gradient because we already have 1 point here to substitute, right? We have 4 minus 6, but we need a gradient. This becomes confusing, especially if you didn't analyze the diagram before and if you forgot what's happening here. We don't have L, obviously, yeah. Like if someone thought, oh, let's find the gradient by using the point L here and the point Q, we don't have L. So when you see that, don't be confused. When you've analyzed it correctly, you remember that, oh, this LQ is perpendicular to what? To SQ or to SN. And we can still see that here. And we reminded ourselves that perpendicular lines have a certain relationship when it comes to the gradient. So we're going to say we're looking for the gradient of LQ. And we know that if we take the gradient of L2 and multiply it with the gradient of SN or NS, we get -1, right? We are calculating this gradient here for now, and then we'll just substitute the other point. This means the gradient of LQ multiplied by 2, because that is what we found in the previous question. If you haven't seen us go through that question in this playlist, make sure you do that, times 2. And then now MLQ is going to be, you just divide both sides. Let's do that explicitly. Divide both sides by 2. And you're going to have MLQ is equals to -1/2. And it looks like we're on the right track because see the gradient there, what we're trying to prove is -1/2. Now you're going to just substitute back here, right? Substitute on your main equation of a line, the general equation of a line. We're going to substitute which point? We're going to substitute 4, -8, because that is the point which is connected, or it is part of LQ. So we're going to sub Q. What is it? Hey, let's go up. It's 4, -8. Right? So that means you're going to have y minus minus 8 is equals to negative half x minus 4, and the rest is computational. You just multiply out. We're going to have y plus 8 is equals to negative 1/2 x plus 2. And then you're going to transpose the 8. It's going to be y is equals to negative half 2x plus 2 minus 8. And that will give us negative half x minus 6. And we've proved that the equation of LQ is exactly what they said it was.